Number 17, an airplane is traveling due east with a velocity of 520 miles per hour. The wind blows at 60 miles an hour at an angle of 30 degrees north of east. Determine the velocity of the airplane's flight. So let's first draw this out to help us out. What do we know so far about the airplane?
It's going northeast.
The airplane's actually not going north of east, per se. It's going due east. So it's actually trying to fly. What happened there? Let's try that again. Vector. So there we go. It's flying due east, 500 miles per hour. Remember, this way is due east. This would be due north. This would be due south. This would be due west. Now, it says something else that happens. It's not the airplane. What else is occurring? The wind. There is wind that's blowing, and that happens to be, it says 30 degrees north of east. What does 30 degrees north of east mean? Does that mean start at north, go 30 to the east, or does it mean start at east and go 30 to the north? It's north of east. So, confusing, but it actually means start east and go 30 degrees north. No, because if it's 30 this way, it would be 60 this way. So no, it would not be the same thing either way. And this is blowing 60 miles per hour. Now, be careful here. We need to make sure, is the wind going this direction, or is it coming from that direction? Let's read the problem. This one says the wind blows at this angle. So it's going this way. Now, I've put them both ways just because I've seen it on the ACP being this way, and I've also seen it coming from this direction. So I want to give it to you both ways. I want you to read the directions clearly. Make sure you get the right answer. So I have two vectors here. Now, mathematically, what happens is this vector here gets attached tip to tail, and it would go over here, and this plane would actually travel, in all reality, would not actually fly due east. It would actually fly on a path like this. Now, that's what actually happens. But as far as the calculator is concerned, we can get our answer pretty simple by adding two vectors. Okay, so all we have to do is add these two as vectors. So let's talk about the plane flying east. Remember, you can write these as one of two ways. You can write them as x and y values, or you can write them as h and theta. And here's the thinking you need to put. If you were to draw this as a triangle, what would each piece represent? This blue piece here, the plane.
Right.
This is the plane. What would it represent in a triangle? An x, a y, or an h?
X.
Because it's an h, an x, you would use this format for the blue vector. So let's write the blue vector. As far as the x-axis is concerned, what happens to the plane on the x-axis? What does the plane do on the x-axis? It goes right 520, and right is positive, so it goes right 520. Now, because you have to include the y value, we need to tell what happens on the y-axis. Does it go up? Does it go down? It just stays, so it's going to stay as a 0. That's the plane's vector. Now we need to include the wind vector. So that's this vector. If you were to draw a triangle with this vector, would it be the x, the y, or the h? Since it's an h, we're going to use this format. So the h is 60, and the angle, for the calculator's purpose, is always from the x-axis, which this is, would be 30 degrees. That's an ugly angle symbol, but that's what that was supposed to be. So now we just go to the calculator. So control parenthesis, it was 520, comma 0, plus 60, comma, angles control book, 30 degrees. Press enter. Now the calculator always gives you the x and y. Basically what it gives you is the location of the airplane. It tells you this airplane is 500, I'm going to round, 572 miles to the right and 30 miles up. That's basically what the calculator gives you first. Does this problem want to know the location of the airplane? No, it wants to know velocity. That would be a magnitude. It wants. So how do we convert it to an H? Menu. Vertical, or you could just do Pythagorean theorem, but this will be quicker. Just type in that way. It does it for us. This means this plane is actually moving about 573 miles per hour at an angle of 3 degrees. So the plane's 573 miles per hour. So question, did the wind help the plane or hurt the plane as far as the speed is concerned? It helped it.